Surface waters include streams, rivers, lakes, reservoirs, and wetlands. The term stream is used here to represent all flowing surface water, from brooks to large rivers. Surface waters and their associated ecosystems provide habitat to many plant and animal species. Because surface waters are on the land surface, they are easily developed for use and provide about 78% of the United States' total off-stream water use. Stream flow varies in response to climatic factors and human activities. Some streams have a small annual discharge for the large size of their drainage area, such as the Colorado River, and some have a greater demand for their water than they can supply without reservoir storage. Because of their importance as a water source, flow rates for selected streams are continuously monitored by stream gauges. Discharge is the amount of water moving down a stream per unit of time. Discharge is the product of the average velocity of flowing water and the cross-sectional area at a selected site on a stream. Average velocity is determined by measuring flowing water at many locations and depths across the selected measurement site. The cross-sectional area and the average velocity at each of these measured locations are multiplied to calculate discharge at that point. The discharges for all locations are added to obtain the total discharge of the stream. Streams are a dynamic part of the environment and are good indicators of what is happening in a watershed. Stream flow in a watershed includes all water contributed from headwater areas, stream banks, channels, floodplains, terraces, connected lakes, ponds, wetlands, and groundwater. Because watersheds are complex systems, each tends to respond differently to natural or human activities. The physical characteristics of a watershed, land use, soil type, geology, vegetation, slope and aspect, and climate control the quantity and quality of water that flows from them. Changes to any of these characteristics can affect water quantity and quality. For example, the removal of vegetation by natural causes such as fire can change the water storage and infiltration characteristics of a watershed. Because burned areas contain less vegetation to slow runoff and hold soil in place, the rate and quantity of water that runs off the surface to streams increases, and so does erosion. During heavy rains, the increased runoff and erosion can result in increased chance of flooding, mudslides, and impaired water quality. Water seeks the path of least resistance. As water flows through a watershed, it picks up and deposits sediments, soil, and rock particles, creating stream corridors. These corridors, which consist of stream channels, banks, and floodplains, are affected by natural and human activities that occur within watersheds. The physical processes of sediment transport and deposition are critical to the formation of the stream corridor. The transport of sediment within and from a watershed is one of the major processes that help shape the surface of the earth. Sediment particles are classified by size, with smallest being clay and the largest being boulders. Smaller particles are usually carried in suspension while the larger materials are moved along the channel bottom by rolling, sliding, or bouncing. One of the major activities of a stream is to transport materials within and out of a watershed. Sediment transport rates of a stream are a function of stream power, which is a measure of the combined effect of the slope at the stream bed. Higher slopes generate higher stream velocities, and discharge, volume of water. Where stream power is reduced, a stream's sediment carrying power is also reduced, and a portion of the sediment is deposited. For example, sediment is deposited following the peak, or highest, discharge of a flood. Sediments can be deposited in channels for short periods of time and moved again or remain stationary as in alluvial fans or in large reservoirs. Stream channels and their floodplains are constantly adjusting to changing water quantities and sediment supplied by their watersheds. Long-term changes in runoff and sediment load may lead to long-term changes in channel characteristics. Surface water is water located on top of land, forming terrestrial, surrounding by land on all sides, water bodies, and may also be referred to as blue water, opposed to the seawater and water bodies like the ocean. The vast majority of surface water is produced by precipitation. As the climate warms in the spring, snowmelt runs off towards nearby streams and rivers, contributing towards a large portion of human drinking water. Levels of surface water lessen as a result of evaporation, as well as water moving into the ground becoming groundwater. Alongside being used for drinking water, surface water is also used for irrigation, wastewater treatment, livestock, industrial uses, hydropower, and recreation. For USGS water use reports, surface water is considered fresh water when it contains less than 1,000 mg per liter, mg/L, of dissolved solids. There are three major types of surface water. Permanent, perennial, surface waters are present year-round, and includes lakes, rivers, and wetlands, marshes and swamps. Semi-permanent, ephemeral, surface water refers to bodies of water that are only present at certain times of the year, including seasonally dry channels such as creeks, lagoons, and waterholes. Human-made surface water is water that can be continued by infrastructures that humans have assembled. This would be dammed artificial lakes, canals, and artificial ponds, e.g. garden ponds, or swamps. The surface water held by dams can be used for renewable energy in the form of hydropower. Hydropower is the forcing of surface water sourced from rivers and streams to produce energy. Surface water can be measured as annual runoff. This includes the amount of rain and snowmelt drainage left after the uptake of nature, evaporation from land, and transpiration from vegetation. In areas such as California, the California Water Science Center records the flow of surface water and annual runoff by utilizing a network of approximately 500 stream gauges collecting real-time data from all across the state. This then contributes to the 8,000 stream gauge stations that are overseen by the USGS National Stream Gauge Record. This in turn has provided to-date records and documents of water data over the years. Management teams that oversee the distribution of water are then able to make decisions of adequate water supply to sectors. These include municipal, industrial, agricultural, renewable energy, hydropower, and storage in reservoirs. Impacts of climate change. Due to climate change, sea ice and glaciers are melting, contributing to the rise in sea levels. As a result, salt water from the ocean is beginning to infiltrate our freshwater aquifers, contaminating water used for urban and agricultural services. It is also affecting surrounding ecosystems as it places stress on the wildlife inhabiting those areas. It was recorded by the NOAA in the years 2012 to 2016, ice sheets in Greenland and the Antarctic reduced by 247 billion tons per year. This number will continue to increase as global warming persists. Climate change has a direct connection with the water cycle. It has increased evaporation yet decreased precipitation, runoff, groundwater, and soil moisture. This has altered surface water levels. Climate change also enhances the existing challenges we face in water quality. The quality of surface water is based on the chemical inputs from the surrounding elements such as the air and the nearby landscape. When these elements are polluted due to human activity, it alters the chemistry of the water. Conjunctive use of ground and surface water. Surface and groundwater are two separate entities, so they must be regarded as such. However, there is an ever-increasing need for management of the two as they are part of an interrelated system that is paramount when the demand for water exceeds the available supply. Fetter 464. Depletion of surface and groundwater sources for public consumption, including industrial, commercial, and residential, is caused by overpumping. Aquifers near river systems that are overpumped have been known to deplete surface water sources as well. Research supporting this has been found in numerous water budgets for a multitude of cities. Response times for an aquifer are long, Young and Bredehoeft 1972. However, a total ban on groundwater usage during water recessions would allow surface water to retain better levels required for sustainable aquatic life. By reducing groundwater pumping, the surface water supplies will be able to maintain their levels, as they recharge from direct precipitation, surface runoff, etc. It is recorded by the Environmental Protection Agency, EPA, that approximately 68% of water provided to communities in the United States comes from surface water. Surface water refers to all the water bodies present on the Earth's surface, from small ponds to vast oceans and everything in between. It includes both freshwater bodies, rivers, ponds, lakes, etc., as well as the saline water bodies, mainly oceans. Rivers, ponds, lakes, etc., constitute freshwater, while oceans have saline water. Surface water mainly originates from rainfall. It is a combination of both surface runoff and groundwater. Surface water is closely associated with groundwater. Some surface water percolates deep into the ground through the cracks and porous spaces within rocks, sand, and soil. The surface water eventually reaches underground springs and wells to become groundwater. Groundwater is fresh and naturally uncontaminated, since the water gets filtered as it trickles through the sediment. However, groundwater is not easily accessible as it is usually located in deeper parts of the earth, often requiring tools or machinery to access it. Surface water is more readily available, but since it is not filtered like groundwater, it is often contaminated by pollution, microbes, and harmful minerals, and must be treated before it is safe to use or ingest. The naturally occurring water cycle helps regulate water and facilitates the exchange between the groundwater, atmosphere, and surface water. Precipitation such as rainfall or snowfall increases the amount of surface water. This surface water will either evaporate into the atmosphere until it condenses enough to form precipitation again, or percolate into the earth to become groundwater. This is how the total volume of water is maintained on Earth. Thank you for watching this video.